So, like Natalie said, I'm going to be talking about what's coming in Go 1.15. This is going to be a fairly quick overview of all the major features and all the major changes that I think are noteworthy. But I should begin by saying, with a big caveat, that these are my personal picks. For example, I'm mostly interested in tools and performance and also testing, but not so much other stuff. So maybe the other stuff is not going to get as much importance as other people might give it. So we are 3 months away from the final Go 1.15 release. The freeze begins in less than a week, I think next Friday. And the final release is due on the first day of August, ideally. Most of what I'm going to be talking about has already been merged, so it's most definitely going to be included in 1.15. And the reason for that is that the freeze is almost here. It's only 5 days away. And it's a good thing that the freeze is taken seriously. So any features that are not going to be merged in the next few days, I likely just left them out because they're not likely to make it into the release. And before we begin, the last thing I want to mention is that this release is smaller than the previous releases because of the current pandemic and issues that people have working full-time these days. And that is okay. Some features have been pushed back to 1.16. Cool. So let's begin with the top 5. So to me, one of the most exciting things is the new linker. If you want to learn more about it, you should follow that link in the slide later. I'm going to post the slide so you don't have to worry about it now. But essentially, the new linker is completely re-implemented from the ground up to be both faster and use less memory by essentially doing less work. For example, it tries to offload some of the work to the compiler. And since the compiler can be parallelized and it can also be cached, it does a far better job that way. That document is very interesting, though, if you want to learn more details. Now, the linker is not yet finished, but the new linker is already being used by default in 1.15 as of today. So it is already a little bit faster, but it's not as good as it will be when it's finished. Also, the binaries produced by Go are a little bit smaller. So I've got an example following up. So this is a small Go program that just downloads a page and then just prints it, right? Obviously, no error checking because I couldn't make it fit in the slide. So if we build it with Go 1.14 and Go master, also called tip, you can see that it's a little bit smaller. It's only about 0.2%, but I think that's a nice win, especially because Go binaries are pretty large. So any small win we can get is going to be incremental and it's going to help in the long term. Another big change that I'm really excited about is that you can now build a static Go binary that includes time zone data. So up until today, if you wanted to load a time zone location with the time package, what would happen is that if the system didn't have that time zone information, it would just error, it wouldn't work. So now you can essentially import this TZ data package, and it is going to be bundled into your package, into your binary. It is going to make the binary about 800 kilobytes bigger, but I think that might be worth it if you want your binary to be very portable and you use this feature. And another feature that I'm really excited about is that you can now create temporary directories for tests with just calling testing.t.temp there, and it also works for benchmarks and the B type. You could do this before, but essentially you had to write the boilerplate 5, 6 or so lines to properly create the temporary directory with the test name and then clean it up later. So now this is all done for you. And the last major feature that I think is noteworthy is that you can now, when you're running as part of a test, you can now ask the testing package, how much time do I've got left to run this test? So until now, if you had a test that was pretty slow or that had to do heavy stuff, it was hard to tell if you could take long or not, because maybe the person that's running the test gave you a 1 hour timeout, or maybe they just gave you 5 seconds as a timeout. So now you can ask it the deadline, which tells you essentially what timeout did the user give and how much time of that do I've got left. So you can write your tests to better adapt to the time that you've got. Cool. So the second section is about ports. I think some of these might not be very interesting to some of you, depending on where you use Go, but I still think they're very important to know. The first one is that 64-bit ARM on Linux is now a first class port. And essentially what this means is that if there are any major issues with this port, it can block a release. So for example, if it's broken, 115 cannot be released without it being fixed. And there are also going to be official release downloads, download links for this port. Another change that's a little bit more incremental in small steps instead of one big step is that 64-bit RISC-V is getting better. So I want to mention 3 examples. One of them is that some math operations like square root are now implemented in assembly, so they're faster. Another one is that the compiler is now learning to generate better code for RISC-V. And the last one is that the compiler can also now generate instructions that use stuff like vector arithmetic, which is very important for some things, depending on what you do. And the last port changes that I want to mention is that 32-bit x86 on Darwin on macOS is being removed. It was already deprecated in 1.14. And the reason it's being deprecated and removed now is that macOS Catalina, which is the current version of macOS, doesn't even support 32-bit applications. So longer term, there's just no point in building Go programs in 32-bit. And similarly to that last point, macOS on ARM 32-bit, which is iOS, is no longer supported because iOS 13 only supports 64-bit architectures. And just as before, this deprecation happened with 1.14. So now we're just seeing the feature be removed. And now we're getting into a much longer section, which is API changes. This doesn't cover every single API change that I've seen happen in 1.15, but mostly the ones that I think are either relevant to most people or relevant to some of you, but it might matter a lot. So the first one is that you can now use fragments in a more powerful way with URLs. So until now, you could, for example, get the path or the query element in its raw format or in an escaped format, but you couldn't do that with fragments. And the fragments is what goes after the pound symbol. Anyway, so you can now do that with fragments as well, which might be useful depending on what servers you're talking to. Another useful feature, if you use passwords within URLs, is that the redacted method is similar to the string method, but it just scrubs away, it removes the password from the string. So if you want to, for example, show this password, show this URL to the user, that would be useful so that you don't leak passwords away. Another useful feature is that you can now reset time.ticker. So for example, if you want to change its duration without dropping it and just creating a new one, you can just reuse it with a new duration. That's useful. Another one that's mainly just a helper to write nicer code, but I think is still important, is that you can now find a regex matches Subexpression by just giving it its name. And until now, what you would have to do is ask the regex, what are all of your subexpressions, and then find the one with your name by doing a linear search. So now you can just do all of this in a single line. Another one is the sync.map type, which is a map re-implementation to provide some atomic operations. So it now also allows you to both load and delete an element in a single step. This one is a little bit lower level, but essentially, if you use either the OS or the net packages in a way that you set deadlines, if you get an error from one such operation, you can now figure out if the error comes from that deadline that you set by seeing if the underlying error is os.error deadline exceeded. Now, this is a little bit confusing maybe, but if you write lower level Go code that uses deadlines, this is very useful. Another one that's a little bit more towards the crypto side is that the crypto/TLS package has now learned a way to talk to TLS servers with a context. So this can be used to, for example, set a timeout when connecting or doing a handshake with a TLS server. Another bit from the crypto packages is that the ECDSA package now has APIs to sign and verify byte slices instead of biggins, which I think we can all agree is more useful in the general case. So moving on to tooling, this is going to be a bit of a mixed bag because tooling is a very broad word, but I tried to encompass anything that I think is useful for developing Go code, for example. So the first change that I think is noteworthy is that there's a new GoEnv variable called GoModCache, and it lets you configure where the Go module download cache is located on your disk. By default, this is within GoPath. I think it's GoPath/pkg/mod or something like that. But now, if you set GoModCache, you can place it somewhere else, which can be very useful for CI, for example, because CI sometimes caches a fixed directory. So if you want to put all of your caches in there, you can use GoModCache. Another change to the environment variables is that GoProxy now allows using fallbacks. So essentially, if you use a special character, which is a pipe, and you try to fetch a module and a proxy responds with an error, for example, I don't have that module, or maybe the proxy is down completely. If you set up this fallback, then the Go command is going to continue on the Go proxy list and then try another proxy. And this can be useful, again, for example, for CI systems. If you want your build and your deploy to be as stable as possible, you might set up 3 proxies and then set it up so that it tries all 3 of them before giving up. There's also been some changes to the vet tool, which is essentially static analysis for Go. It is run as part of GoTest these days, so this might be transparent to most of you. So this is a little bit hard to explain, but essentially, if you convert an integer to a string, it doesn't do what some people might expect. For example, if you try to convert the number 10 to a string, it doesn't give you a 2-character string with 1 and 0. It takes the 10 as a rune, which I think is a new line, and it just gives you a string with that single character. So there's 2 things you might want here. If you want to convert the integer to an actual number, as in the 10 to 2 characters, 1 and 0, you should use the strconf package or the fmt package. But if you really do want to convert an integer to a rune and then to a string, you have to do that explicitly. So you convert the int to a rune and then the rune to a string. And that is going to do what this currently does now. But the current string to int conversion is confusing. So vet is going to complain about it because it's essentially going to push you to one of the 2 less confusing routes. Another change in vet is that impossible interface assertions are now going to be an error. So for example, if you have an interface that has a method called read with 1 signature, for example, returns error, and then you try to type assert to another interface with the same read method, but it returns an int, now vet is going to complain because that can never be satisfied. Another change is that the compiler now has a Spectra flag. And what this does is it lets you enable some Intel speculative execution protections. So the only one that's implemented now is that you can avoid speculation past index bounds checks. So this might be useful if you run Go in some sensitive environments or dealing with sensitive data. You can look at the CL and decide for yourself. It is not enabled by default, by the way. And the old export format support is also removed. The compiler has been producing a new export format for a few years now to essentially be faster and allow using the export data for packages faster. But the old support for the old format was still there. So now that's been removed. I'm not going to explain why that is or why the change was done, but if you want to learn more, you can just follow the link later. And also, when it comes to test caching, the Go tool decides whether or not running a Go test command should use the test cache or not. So for example, if a test succeeds and you run the same command, the same Go test command twice, it should in theory cache the test result. But until now, even if you change the timeout flag, it would still try to use the cache. So now it's learned that if you use, for example, a shorter timeout, it shouldn't just reuse the cache because a shorter timeout might make a test fail or a longer timeout might make a test succeed. Another one is that the lines that you have before a declaration without an empty line called a GoDoc, until now, if you wanted to include a directive, a Go directive as part of those lines, you couldn't because the //go : line would be included as part of the Go doc. So what you would do is keep a separate line, keep an empty line between the Go line and the Go doc. So now the Go tool has learned to essentially skip those Go colon lines when it's building the Go doc string for a declaration. Another change that I think is pretty small but useful is that you can now println with a function call that returns more than one value. So before, what you would have to do is declare multiple variables in a separate line and then println those. And this was just a silly limitation in the compiler. Now the spec doesn't say that this should work because the spec doesn't cover println, but still, it's a nice change to help debugging Go code quickly. Another change that's pretty low level, but that might be useful to some, is that if you panic with a value and that value is behind an address, behind a pointer, but the value itself is printable, the panic message is now going to print the value directly instead of just printing a pointer. And I think we can all agree that if a value is printable, you almost always want the value directly. You don't want the pointer to it. So this is going to make some panic messages more useful. And the last bit is performance. I think this might be the most interesting to some of you. The details here are going to be maybe a little bit more complex to understand, but like I said before, we can delve into the details later. Now, a write barrier in Go is essentially a protection to accessing a pointer in the heap, and that is because the concurrent GC might be running, and the GC has to look at those pointers again. So the write barriers on AMD 64, on 64-bit x86, they got a little bit faster because they now use registers better. So binaries get about 0.5% smaller, depending on the binary. And depending on what you do, if it deals with a lot of pointers, it might be a little bit faster. And mid-stack inlining, what that means is inlining a call to a function that calls other functions. So until now, that couldn't happen if this mid-stack call happened inside a recursive call chain. So now that's allowed in certain scenarios. So for example, Go has a generic benchmark suite, which benchmarks a bunch of pretty standard Go workflows. And that got about 0.6% faster. Now, that is exciting. It's good news. But at the same time, you should benchmark your own code to see how it's affected by this change. And also in Linux, if you use for ConnectSec, which happens to when, for example, you use exec.command, it's now going to use a single syscall on recent Linux versions. I think it's after 2.6.27 or something like that. And the reason being that dup3 is a newer syscall, and it lets us do all that we need to do in a single syscall instead of doing multiple syscalls. And again, this might help some programs you should benchmark by yourself. SHA-512 is also 15% faster, and that is simply by helping the compiler a little bit. The code was using a function literal, so now that's been refactored away to make the code simpler, and that the compiler can do a better job. And ReadMemStats from the runtime package, what that does is it lets you ask the runtime stats about memory usage, such as how much heap are you currently using, how many objects in the heap are there currently. So until now, the latency for this could be pretty bad if the GC was running at the same time. So now the GC has been refactored a little bit in a way that GC and ReadMemStats can run at the same time, kind of. So that means that if you use ReadMemStats, the latency is way, way down because it's no longer affected by GC runs as much. Receiving on a closed channel used to be kind of slow compared to other channel operations, and now it's almost entirely a no-op. It's really fast. And this is an edge case, but depending on what you do, it might matter a lot. Converting small integers to interfaces is now doesn't allocate anything. And the reason is because the runtime now has a static array with 256 elements. So, and each one of those is an integer from 0 to 255, sorry. And so if you convert any of those integers to an interface, it is essentially just going to take a pointer to one of those elements in the array. So it doesn't need to allocate a separate integer each time. Again, this is going to depend a lot on what you're doing with your code. Another change that's pretty low level, but that might matter a lot depending on what you do, is that the way that Go checks for CPU features for a CPU. So for example, asking, does the current CPU have vector instructions, or does the current CPU have crypto instructions? It's now done with compiler intrinsics. And what this essentially means is that it allows the compiler to generate better code to check for those. So before, it used to do a memory load and do a lot of heavy things. And now it's essentially really fast for the simple cases. So some things like using math.fma, which is a pretty common math instruction, it's now really fast because it can essentially generate good code. So if I can give any parting thoughts here, is that most of what I've talked about here, I've learned by just reading, skimming over the commits that go into master. Now, I'm not saying that I read every single commit on every single line, and I'm not saying that you should do that either. But if you want to learn more about Go and what changes are going into Go on a daily or weekly basis, I do recommend that you consider that, because I learn a lot. And even if I don't understand everything, it is a good way to see, oh, that sounds interesting, I'm going to learn more about it. And even though Go 1.15 is still 3 months away, the first beta is about 5 weeks away. And if you can try master today by running the command that you see on the screen. So thanks for your time. And now we can move on to questions.
Thank you very much, Daniel. We have some time indeed, and we have some questions. So we're starting with 4 questions and see how that develops. Do you think Go is trying to totally distance itself from C with these new changes, especially with generics?
That is a difficult question. I didn't talk about any of these big language changes because I don't think Go 1.15 includes any. I do think that Go tries to be better than old languages like C, in the sense that you should be able to write higher level code that's powerful, but at the same time safe. So I do think that in a way, generics is kind of gaining something that we lost moving from C or other languages, such as such as templating, or such as the preprocessor. Go doesn't have anything like that other than the Go generate. So in a way, it is kind of getting that back. But at the same time, I worry that we get too close to the languages that have too many features and they compile too slowly. Mm-hmm. So I don't know, to be honest.
Okay. Speaking of features from other languages, are there news about generics? Is there anything planned, or is it finally going to be a Go 2 version?
I don't think there's going to be a Go 2 version. What they said a few months ago, or maybe even last year, is that they're not going to have a Python 2 versus Python 3 situation where the language changes so drastically that the community splits in two. The recent Go versions have already had some incremental changes, and I think they are going to continue with that. Obviously, generics, if it happens or when it happens, is going to be a large change, but I still think they're going to try to make it in a way that's incremental. Mm-hmm. As for ETAs, I've seen some progress in it internally, but I don't want to say anything about it because I'm not the person working on it.
Is there any big change for error handling?
Error handling. I think the last major event there was the try proposal from Robert Griesemer. I think that was a controversial proposal. Lots of people were fully for it. Lots of people were angry about it. And I think the result of that is that the Go team is a little bit cautious with continuing with their handling right now. So I do think they want to do something about it. And for example, Brad made a proposal to convert errors to Booleans in if conditions. Mm-hmm. But I think for now, they're letting things sit for a while.
If I have apps using an old Go version, is it worth to spend the time updating to 1.15? Is it easy to justify for the business?
If you have what, sorry?
Could you repeat the answer?
Sorry, you said if I have, and then I didn't understand.
Oh, if I have apps using an old Go version, would it be worth to spend the time updating it to 1.15? And is it easy to justify it to the business?
I think it depends on what your trade-off is. I think currently Go supports 3 major versions at a time. So if the current major version now is 1.14, even Go 1.12 is getting is getting important bug fixes and security fixes.
Mm-hmm.
So if you want the most stability possible, I wouldn't say you're in a rush to update as long as you're on a version that's maintained. But at the same time, if you have no reason to be extremely conservative, I would say that newer versions are better, simply because Go is getting a little bit better at each release. So I personally update. So I work for a company, and we update to the new Go release, and we test it out as soon as it comes out, essentially. And I think everybody should try to do that if it's worth for them.
Okay. How would Go Mobile / Geo work on an older iOS architecture without the support for it? Would it just use Go 1.14 while building for it?
That is a good question. I think I could answer this in multiple ways. One of them could be, if 1.14 works for you and you need to support older devices, you can stick with it for 6-12 months, because like we said before, it is going to be supported for a while. On the other hand, something like Geo is new technology. And if you're building for older devices, that's kind of a mismatch between new technology, old platforms. So if you want to prioritize older devices, I'm just guessing here, but maybe something like Go Mobile, which is more stable and older, might be a better solution for you. But again, I think you should ask this first to somebody like Elias, who works in Geo instead of me.
All right, that's all for questions from the crowd. And the most important question, what is this in my background?
So it's called a Yorkshire pudding. It's essentially a kind of soft bread that people eat in the UK. You can put gravy in it. You can put lots of vegetables or meat on it. And I think it's great. Some people from my hometown in Barcelona might throw rocks at me for saying that, but...
All right, we hope you stay safe. And thank you so much for the time. Thank you very much for answering all the questions. And if anybody else wants to ask you more questions, Twitter is the place to go to. You can find Daniel's handle in the retweets from the conference, which is GoRemoteFest.